Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll go through how to graph simple exponential functions. So by simple exponential function, I mean one whose equation is of the form y equals something times something to the power of x. So remember, what makes it an exponential function is if the x is part of the power or the exponent. So let's start by graphing a simple one, y equals 2 to the power of x. So we're going to draw up a table of values. So remember, for a table of values, I pick the x values, so I'm going to pick some positive and negative ones, and for each of the x values, I just substitute in the equation here to find the y value. So if x equals minus 3, y equals 2 to the power of minus 3, which is 1 over 8, or 0.125. 2 to the power of minus 2 is 0.25. 2 to the power of minus 1, 0.5, and so on. So what we can see here is even when x is negative, y is positive. In fact, the equation 2 to the power of x equals 0 has no solutions. 2 to the power of x is always positive, because even if x is a really large negative number, y will just be a really small positive number. So straight away we can see that there's actually an asymptote of this graph. It's actually at y equals 0, or the x-axis. This graph will never hit the x-axis because 2 to the power of x can never equal 0. The y value can never equal 0, so this is an asymptote. So unlike hyperbole, which we did earlier in the year, exponential functions have only one asymptote. They only have a horizontal asymptote, not a vertical asymptote as hyperbole do. So the reason there's no vertical asymptote, there's no value x can't take. You can raise 2 to any number you like. It's just that the whole thing can't equal 0. So let's just draw in this asymptote and then plot these points. So minus 3.125 and then minus 2.25 will be about there. And then minus 1.5 will be about there. So then 2 to the power of 0 is 1, goes through there, 1, 2, 2, 4, and 3, 8. So as I showed you in previous video, hallmark of exponential functions, y equals a to the power of x, they get big really quickly. So let's join up these points. So this is the graph of y equals 2 to the power of x. And if I change this value here to like 3 to the power of x, 4 to the power of x, whatever, it still has the same shape. So this is what y equals a to the power of x looks like. It's very, very close to its asymptote. So as x is getting more and more negative, it gets very, very close to its asymptote. But as x gets positive, it goes through y-intercept of 1 and it gets big really quickly. So let's change the number. Let's try y equals 4 to the power of x. Well, y equals 4 to the power of x will be the same. We'll get very, very close to its asymptote, and it will also go through this y-intercept of 1, because 4 to the power of 0 is 1. The only difference between these two, however, is that this one will get bigger quicker. Instead of going through 1, 2, if x equals 1, y equals 4 to the power of 1, which is 4, and at 2, x equals 2, y would be 16. So the graph is going to look like this. So you can see these two have the same shape, it's just y equals 4 to the power of x gets larger quicker. So the larger this number is, the quicker it will go up. So let's now try graphing y equals 1/4 to the power of x. So this time the a value, the number that's being raised to the power of x, is less than 1. So we could also draw up a table of values here. So you can just put these in your calculator. It turns out 1/4 to the power of negative 2 is 16. So this graph would go through the point minus 2, 16, which is up here. 1/4 to the power of negative 1 is actually 4. So it will go through here. Now 1/4 to the power of 0 is 1. Anything to the power of 0 is 1. 1/4 to the power of 1 is 1/4, 1/4 to the power of 2 is 1 over 16, and so on. So the graph of y equals 1/4 x looks like this. So it turns out this green graph here is actually a reflection about the y-axis of y equals 4 to the power of x. That's no coincidence. See, a quarter to the power of x is the same as 4 to the power of negative x. And hopefully you remember from functions, if you take a function and replace x with minus x, you reflect it about the y-axis. So if you're graphing y equals a to the power of x, if a is greater than 1, it's one of those increasing exponentials we referred to in the last video. It'll go up like that. And if a is less than 1, as it was in the green graph, it's a sort of a reflection. It goes like that. So let's try multiplying the graph by a number. So let's now try and graph y equals 3 times 4 to the power of x. So this is the same as the red graph y equals 4 to the power of x, except the 3 just dilates it. It stretches it. It makes the y value 3 times as large. So instead of this going through the y-intercept of 1, it will go through y-intercept of 3 times 4 to the power of 0, which is 3. Its y-intercept will be here. Instead of going through the point 1, 4, it's going to go through the point 1, 12. So other than that, it's the same graph. It still gets closer and closer to 0 as x gets more negative. All it does is just change it enough so the graphs kind of look parallel. So it just stretches it out a bit so it gets bigger a little faster. So that's the graph of y equals 3 times 4 to the power of x. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.